All right, moving on with the next bit of the same section. We're still going to be using that rational root theorem, except now we're going to be diving into complex numbers. I talked to you in class today about the conjugate pairs theorem, which just says that if you have one complex number that's a root of a polynomial, its conjugate must also be a root. So I put three complex numbers right here. The conjugates are, you simply change the sign in the middle. So the conjugate of 2 minus 5i is 2 plus 5i. If I tell you that negative 3 plus 8i is a root of a polynomial, then you know that negative 3 minus 8i is also a root. You simply change the sign in the middle. Now the bottom one, just 6i by itself, tends to confuse people. You could think of 6i as 0 plus 6i. That way it looks like the rest, a number plus an imaginary number. And the conjugate of 0 plus 6i would be 0 minus 6i, or just negative 6i. So if all you have is the imaginary part of it, just the bi part, an a plus bi, then you just do the opposite sign of it. So those are conjugates, and we're going to be using those in just a minute. But for now, the first kind of problem I wanted to look at is the exact same thing we were doing in class today, except I'm going to get the ball rolling for you. In class, what I gave you was, hey, what happened to my problem? There it is. You shouldn't do that to me. Okay, in class, what I gave you was, I only gave you the polynomial. I just said find all of the roots. You listed factors of 12 over factors of 1. You looked at the calculator. You tested them. But what I'm going to do this time is I'm actually going to help you out. There are 4 roots because my degree is 4, but I'm going to give you one of the 4. So I'm going to go ahead and get you started. And if I give you one of the 4, what I can actually do with that one is do synthetic division to clean my function up just a little bit. I have 1x to the 4th, 2x cubed, negative 7x squared, negative 8x, 12. If I do synthetic division with this, bring down the 1, negative 2, 0, 0, negative 7, 14, 6, negative 12. So I do synthetic division. I do get 0, which I should. That confirms that negative 2 is a root. Now my new polynomial, I've got some function. It's plus 6, that's x squared, or x squared, 1x cubed, plus, and I will go ahead and say 0x squared, so I have that place filler, 7x plus 6. This is my new polynomial, and I'm going to find the zeros of this. There are 3 of them. I'll do factors of 6 over factors of 1, and I'm going to pause the video while I do that. Okay, so I listed my factors of 6 over factors of 1. I've already looked at my calculator, and I think these are my 3 roots. And now I'm going to test them with synthetic division. So I do negative 3, and I'm going to do it into this function, 1, 0, negative 7, and 6. And I should get 0. I'm hoping I do. 0 minus 3, negative 3 times 3 is 9, negative 7 plus 9 is 2, negative 6, I get a remainder of 0. That confirms negative 3. Now I'm going to do the same thing, but I'm going to move on to my next guessed root. I think it's 1, so I'll try 1. 1 times 1. 1 times negative 2 is 0. And then, since I have my third one, usually what I'll do, once I get that, this part is I'll write 1x minus 2 and I'll solve the equation. But since I think 2 is, I'll go ahead and test 2 also. I'll bring down the 1. 2 times 1 is 2. Negative 2 plus 2 is 0, which confirms that that was a root. And that shows my next 3 roots. So x equals negative 2 was given, and then negative 3, 1, and 2 are my other 3 roots. So x equals negative 3, 1, and 2. And that way, when you have the one root already given, you can get the ball rolling and clean your function up a little bit. So let's try another one. Let's do, hey, blank page. Woo, let's try Triangle Man. Triangles. Woo. All right. There's our Triangle Man. He's happy. Okay. This function, same thing. I'm giving you a proposed root, or I'm telling you that that is a root. So since that is a root, I can do synthetic division with 3 and clean up my polynomial. 2, negative 5, negative 15, 30, and 18. And then I will do synthetic division to whittle that down. So 6, 1, 3, negative 12, negative 36, 30 minus 36, 3 times negative 6, and we get a remainder of 0, which we should have. And now I'm left with a polynomial, y equals 2x cubed plus 1x, minus 1x squared minus 12x minus 6. And I'm going to list the possible rational roots, and then we're going to find the roots of this one. Alright, so I listed my possibilities, and I graphed this polynomial 2x cubed plus x squared minus 12x minus 6. I graphed that one, and this is what my other three roots look like. Now, if you look at these, negative 1/2 is one of my possibilities, so I've already set up to test that one. But my other two, negative 2.5 and positive 2.5, those are not possibilities anywhere. So I know I'm not going to waste my time testing those. So those, even though I do know I'm going to have answers in that vicinity, they're not rational roots because they didn't show up in my possibilities. So let's clean up with negative 1/2. I'll bring down my 2. Negative 1, that's 0. 1/2 times 0. I know my 0 times tables. Do you? See, that'd be 6. Negative 6 plus 6 is 0. And this is what I'm left with. Since I have no other viable options to check, I did just verify negative 1/2. I'm going to have to solve the rest of this with algebra. So I have negative 12, 0x, and 2x squared. 0x and negative 12. And I'm just going to set that equal to 0, and I'm going to solve it. I'm going to add 12, divide by 2, and you get 6. And then when I take the square root to solve the equation, anytime the square root is your creation, you have to remember plus or minus. So I get x equals plus or minus the square root of 6. And if you punch that in the calculator, you will get plus or minus 2.44-ish, somewhere in that vicinity. So that's why my negative 2.5 and 2.5 didn't show up, because it was actually the square root of 6. It was an irrational root. So we have two irrational roots, root 6 and negative root 6, and then negative 1/2 and 3 for the other two. Yeah? Good. Okay, this problem, this one's going to get a little bit hairy because the root that I give you this time is imaginary. It's a complex root. But the good thing about that is I told you about the complex root theorem, or the conjugate pairs theorem. If you have one complex root, you automatically know its conjugate is also a root. So I'm going to go ahead and say that negative 3i is a root. I should have 5, so that's 2 of my 5. I've already found them. I'm going to do the exact same thing with 3i and negative 3i that I have been doing with the proposed roots and the other problems. The only difference is this time it's an imaginary number, which opens up a whole new can of worms when you do the synthetic division. And yes, you can do synthetic division with complex numbers. You have 4x to the 5th, 23x cubed. Oh, 23x cubed. What do you notice there? There is no x to the 4th, so you have to watch out for those. 0x to the 4th, and you will need to leave a little bit of space with the complex ones. Hey, what's that?
Hey, you still get this card stock?
Oh, my mom just called me over the intercom. Now that was cool. How many of y'all get messages from your mom while at school? Alright, so let's see. 23, 6x squared, negative 117x, and 54. And these do require a little bit of space, and you'll see why in just a minute. Now I'm going to follow my normal synthetic division rules. I'm going to bring down the 4, multiply 3i times 4 is 12i. 0 plus 12i is 12i. 3i times 12i, well, 3 times 12 is 36. I times I is I squared. But if you remember today, I told you all that I squared is equal to negative 1. We're going to use that a lot. So this is really saying 36 times negative 1, which is negative 36. So let's see. 23 minus 36 is what? Negative 13. Okay, so 3i times negative 13 is negative 39i. Now I have 6 minus 39i, which doesn't combine. And now I have to distribute 3i through all of this. So I'm going to do that down here. 3i times 6 minus 39i. 3 times 6 is 18i. 3 times 39, 39 times 3 is 117. And that would be I squared, which would actually make it plus 117. So we have 18i plus 117. And the 117's cancel, leaving with just 18i. And then 3 times 18 is 54. I times I is I squared, which actually makes that a negative 54 and gives me a remainder of 0. So while it's a little bit hairy, you will still get a remainder of 0 because I told you that 3i was a root. So now I'm going to do the same thing, but this time with negative 3i. And I'm just going to prepare you right now. This is about to be downright sexy. Watch this. Just be prepared for amazitude. Yeah, I just made up a word, amazitude. So I'm going to bring down the 4. Negative 3i times 4 is negative 12i. And, oh, check that out. Canceled. Negative 3i times 0 is 0. Negative 13. Let's see. Negative 3 times negative 13 is 39. And I have an I. And, oh, look, the complex number canceled. So negative 39 plus 39 is 6. Negative 3i times 6 is negative 18i. And that went away. And notice, when I did the division with both complex roots, I ended up with a sexy polynomial, 0x squared minus 13x plus 6. And now I can find the remaining roots of this using the rational root theorem. So I'm going to pause it and get that done real quick, and I'll show you the answers. Alright, so I listed my possibilities. I looked at the calculator, and this is what it looks like the roots are. I've got 1/2, and I only wrote 1/2 because I'm pretty confident that that's it. But I also have 1/4 that might be the solution. So if 1/2 doesn't work, then I'm going to try 1/4 after that one. So I just want to point that out. Also, if you're trying to work this, if you want to pause the video for a minute and work ahead of me and see if you can get this to work, because I just thought about this. When I pause it and unpause it, it's like it's a split second to y'all who are watching the video, although it takes forever for me. Anyway, so if you want to work it out, pause the video for a second, and I will work this out, and I'll unpause it with the answer. Okay, I just did the synthetic division with those 3, and they did work. So my roots are negative 2, 1/2, 3/2. Those are the 3 I found. 3i was given, and negative 3i I was able to find based on the conjugate pairs theorem. So there's that one. Okay, let's try another one, except this one's a little bit hairier. The complex root I gave you this time is 2 plus 3i, but then I can automatically say 2 minus 3i is a root, and there are 4 total, so I just found 2 of the 4. And what I'm going to do to make this a little bit easier is I'm going to do synthetic division with 2 plus 3i. So let me set that up real quick. Okay, so I have it set up now. And when I multiply, so I have 2 times, and we have to distribute all the way through. So 2 times 2 plus 3i is going to be 4 plus 6i. So negative 13 plus 4 is negative 9 plus 6i. And now when I multiply this, this is going to take a little bit of time because I have to actually FOIL all that out. So I'm going to go over here on scratch paper land. 2 plus 3i times negative 9 plus 6i is, let's see, 2 times negative 9, 2 times 6, 3 times negative 9, and 3 times 6. It'd be I squared. Then we combine our like terms. 12 minus 27 is negative 15i. And then negative 18, and remember, I squared is negative 1, so when I say plus 18i squared, that's really minus 18. That's going to be negative 36 minus 15i. So I multiply, write that up here, then we have to add. So 43 minus 36 is 7 minus, I forgot to write my I, 15i. And then I have to FOIL it out again, so I'm going to pause it and do that. Okay, so I've multiplied it. You can see my work down there, and I got 59 minus 9i. So now I'm going to add that. Negative 53 plus 59 is 6 minus 9i. I know this is going by really fast to you because I'm pausing as I do the little tests, but if you need to pause it and kind of look at what I did when I multiplied 2 plus 3i and 7 minus 15i, you can do that. But right now I'm about to pause it again because I have to multiply 6 minus 9i times 2 plus 3i. Alright, so I multiplied those, and you should get everything to cancel. I should get 39 because since I told you this is a root, I should get a remainder of 0, and I did. So I've done one round of synthetic division. Now I'm about to do the second round. Now I know you may be thinking this is terrible because now I have to do this all over again, but remember, the second time you do synthetic division with the complex root, the second go-round is just downright sexy, I'm telling you. And I'm not even going to have to pause this one because it usually goes pretty quick. I'll bring down the 2. 2 times 2 is 4. That'd be minus 6i. And look, the imaginary number's canceled. So negative 9 plus 4 is negative 5. And I'll distribute the negative 5. Negative 5 times 2 is negative 10. Negative 5 times negative 3 is plus 15i. The i's cancel. 7 minus 10 is negative 3. Negative 3 times 2 is negative 6. Negative 3 times negative 3i is positive 9i. And those all cancel and you get a remainder of 0. The second go-round is always going to be nice and sexy. So I just verified those two roots. And now I'm down to, I have 2x squared minus 5x minus 3. And I need to find the roots of that. You could do the rational root theorem, but you know, this is a quadratic. You can use quadratic formula, or you can factor, which I believe this will factor. I'm always going to try to factor first. If it doesn't factor, then I'll do quadratic formula. Let's see, I think 3 and 1. Nope, that's not going to work. It's 1 and 3. If I get a negative, 3 times 2 is negative 6, plus 1 times x, that works. So I just factor it, and you get x equals negative 1/2, x equals 3. There are the other two roots. Here are the two complex roots, and there were 4 total. So that gives me all of my roots using the conjugate pairs theorem. How do we feel about that? Pretty good? Pretty good. So we're looking at 16 minutes. Okay, one more thing real quick. I'm going to try to make this fast. Write a polynomial that has the following roots. Now, this is going to be a lot easier than what we were just doing, and I probably should have started with this, but I decided I would end the video on something simple. Here we're going absolutely backwards. I'm giving you the answers, and you have to work back and give me the polynomial. In these other problems, I was giving you the polynomial, and you had to give me the roots. So now we're going the other way. I'm giving you the roots, you give me the polynomial, but it's real simple. If I have a root of x equals 1, that means I started with a factor of x minus 1. And if that doesn't make sense, look at the way I solved this factoring. I had a factor of x minus 3. Well, the factor of x minus 3 gave me the answer of positive 3. And that's exactly what I'm doing here, just in reverse. If I have an answer of 3, that means I had a factor of x minus 3. If I have a root of negative 2, that means I had a factor of x plus 2. If I had a root of 5, that means I had a factor of x minus 5. And I'm going to keep this real simple. Your polynomial is x minus 1 times x minus 3 times x plus 2 times x minus 5. And I will let you stop right there. If you want to completely multiply it out, you can. It takes a whole lot of foiling, but I'm fine if you stop there. So if I give you the roots, you find the factors, and you just write it out like that. Good? Let's try another one. Here, I have x equals 5, so that's going to be a factor of x minus 5. The 2/3, we're going to come back and look at that. X equals negative 1 is going to give me a factor of x plus 1, but I told you that it has multiplicity 3, which only means we have to put the cube there. All right, let's look at x equals 2 over 3. What we're going to do with this, to get your root, some of y'all may be able to see what it is, but if you don't, we're going to unsolve this equation. I'm going to move everything back over with the x. And what I'll do is I'll multiply by 3 to undo the fraction, and that's going to give me 3x equals 2. And then I'm going to move the 2 over with that, so I'm going to subtract 2, and that'll give me 3x minus 2 is equal to 0. And 3x minus 2 is the root that belongs to x equals 2/3. And some of y'all are going to have the ability to simply look at it and spit out the factor, and I'm okay with that. If you don't, then you just have to unsolve the equation. And actually, there's your polynomial. Once you list the factors, just draw a box around it and move on with your happy life. Good? You're good? All right, let's do 2 more real quick. X equals negative 2 with the multiplicity of 2, so that's going to be x plus 2. Multiplicity of 2 means squared. X equals 1/2. I would multiply by 2. If I do that, I'll get 2x equals 1, and then I'll move the 1 over. 2x minus 1 equals 0. Basically, it's weird. Some people call it solving for 0, where you just undo the equation. So I have a factor of 2x minus 1. Now this other one, x equals 5i, that's a little bit of a trickier one, because x equals 5i gives you a complex root also of negative 5i. Remember, complex roots always occur in pairs. So what I'm going to do with that, I will take each one of those, and I'm going to unsolve the equation. Oh, let me write negative 5i over here. And I'm going to unsolve the equation, so if I move that 5i over, that gives me x minus 5i equals 0. So there's one factor, x minus 5i. And my other one, if I move this 5i over, I'm going to add 5i. That's really hard to say. Bye-bye, 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 bye-bye. Okay. And so there's x minus 5i and x plus 5i, and that's your polynomial, but I want you to go one step further. When you go one step further, I don't want imaginary numbers in your answer. Now, these factors over here have no imaginary numbers, nothing complex, so I'm happy with that. We're not going to change those. These, we're going to multiply out. We're going to expand those because I want to undo the imaginary number. So I'm going to expand anything with imaginary numbers. So x times x is x squared. X times 5i is 5ix. Negative 5i times x is negative 5ix. Negative 5 times positive 5 is negative 25. I times I is I squared. And what happens here is the I terms will always cancel, except for the I squared, sorry. But the I to the first terms will cancel, 5ix minus 5ix. And remember, negative 25i squared, that's the same as plus 25. So we're down to a factor of x squared plus a 25. And then these two will just come along for the ride. X plus 2 squared and 2x minus 1. So y equals those, and yeah. And once again, I fail at keeping the video short, 21 minutes. I guess that's just going to be the norm. I'm sorry.